Lesson 2 notes are solving systems using two different methods, substitution and elimination. So we already learned the first way to solve a linear system is by graphing and finding their intersection point, or determining that they do not intersect or that they are the same line. We also learned how to solve linear systems of inequalities, where we graphed the functions and shaded their solution regions, looking for the overlap. These two methods are non-graphing methods for solving systems. The first way is called substitution. So the substitution method is used when to eliminate one of the variables by replacing it with the other variable. The substitution method is preferred when one of the variables has a coefficient of 1 or is easily solved for. Okay, so if you look in number 1, the second equation is already solved for y because it is written y equals negative 3x. And so to use substitution, we will go to the first equation, and in place of that y, we will substitute in negative 3x. So it would look like this: 2 parentheses negative 3x subtract 3x equals negative 18. And so now what we have is an equation with a single variable that we can easily solve. Negative 6x minus 3x equals negative 18. Negative 9x equals negative 18. X equals a positive 2. To complete the solving, we will take that value 2 and we will substitute it back into one of the equations and solve for y. So if I go to the second equation, y is equal to negative 3 times 2, which is a negative 6. Now we know that if we were to graph this, that the values that we just found would end up being a point in the coordinate plane. And so traditionally, when you write the solution to a system, you write it as an ordered pair. So 2 comma negative 6. So substitution, solve for one of the variables. So in this case, it was already solved. Substitute into the other equation. All right, for part B, I will get you started and then I'm going to let you finish and pause the video and let you type in your solutions. So to begin, we want to solve for one of the variables. So I look at y, I see that it has a coefficient of 1. So I'm going to subtract the 2x to the other side. So y equals negative 2x plus 9. So I'm going to pause the video now. I'm going to let you substitute that into the first equation and complete the problem to determine the solution. Okay, let's see if you got it right. So we're going to take this right here and we're going to substitute it right there in that first equation. So 3 times the quantity, negative 2x plus 9 minus 2x equals 11. Now when you do that, you have to remember to distribute carefully. So negative 6x plus 27 minus 2x equals 11. Negative 8x plus 27 equals 11. Negative 8x equals 11 minus 27, which you can do with or without your calculator. It turns out to be a negative 16. Divide by negative 8, so x equals a positive 2. Now you can take that positive 2 and you can substitute it back into either equation to solve for y. So y equals negative 2 times 2 plus 9. That's negative 4 plus 9, which is 5. So your solution is 2 comma 5. So did you get it right? That is solving systems by substitution. So the idea is that you substitute one of the variables so that you end up with a singular equation with one unknown. A second way to solve linear systems and nonlinear is called the elimination method. And what it means is that you will combine the equations in some way by adding them. And in combining them, your goal is to eliminate one of the variables so that you have a single variable left to solve. You may need to manipulate these equations, multiplying them by a positive or negative number before you add them together. When you see opposite numbers in front of one variable, you know you can add to eliminate. So the first thing you should do when you're asked to solve by elimination is scan the coefficients of the x's and the y's and see if any of them are opposite numbers. So if you look at A, we have a 6, a 3, a -4, and a 7. So none of them are opposite numbers, all right? And so we can't just instantly add the two equations together because neither variable will drop out. And so what we're going to have to do is manipulate the equations so that we do have opposite numbers in front of one of the variables. So the second equation already has a negative in front of the x. So I'm going to manipulate the first equation by multiplying it by 4. And I'm going to manipulate the second equation and multiply it by 6. So I'm multiplying through the whole equation by 4. So that's going to be 24x plus 12y equals 27 times 4, which you might want to have your calculator handy for. That's 108. In the second equation, we're going to get negative 24x plus 42y equals 27 times 6, which is 162. So you can see that I have now created the two equations where the number in front of x is opposite of the number in front of the other x. So that if I add, so let me write this down, add to eliminate, you will literally add down. So you will add these two and they drop out. You will add these two and that's going to give you 54y. You'll add these two and that's going to give you 170. We're going to take 170, we're going to divide by 54, and it comes out to be, it doesn't come out to be a nice number, so it comes out to be 170 over 54. Okay, and the reason that it doesn't come out to be a nice number is because when you add, you get 270, not 170, and 270 divides 54 5 times. So be careful when you're adding there. Now we're going to take that y value and substitute it back into either equation to determine x. So 6x plus 3 times 5 equals 27. 6x plus 15 equals 27. 6x equals 12. X equals 2. So my solution is 2, 5. And you do write the solution x, y. All right, so let's take a look at the second equation, set of equations. And again, we do not have any opposites in front of any of them. And so we will have to choose which variable we want to eliminate. And so I'm going to just keep eliminating the x's, but you can pick either one. And so I'm going to manipulate that top equation by multiplying through by a -3. And that's going to be negative 6x minus 9y equals negative 18. And then this is going to be 6x plus 9y equals positive 18. And what happens is both of the variables drop out, and I end up with a true equation. 0 does equal 0. This is an indication that those two equations were exactly the same line if you were to graph them. So these are the same line, okay? Infinitely many solutions. And if you go back to when we were referring to this type of system is consistent dependent. So consistent dependent. And dependent. So they are the same line. All right, now those are two examples of solving two equations, two unknowns, all right? We can also solve systems where there are three equations and three unknowns. And these take a little bit longer, but we're using the same types of methods. We're either substituting or we're eliminating, all right? So I'll show you three types, and then you can try one on your own. So in the first one, we see that the third equation has a single variable in it. In the second one, we see we have a y and a z, and then in the first one, we have an x, a y, and a z. So scan the equations to see if you can solve one of the equations for one of the variables right away. And in this case, we see that z is 4. We can then take that value and go to the second equation and substitute in 4 and solve for y. So that's going to be negative 5y equals negative 5. Y is 1. And now we can take both of those values and substitute them into the top one to determine what x is. So 2x plus 3 times 1 minus 5 times 4 equals 13. So that's going to be 2x plus 3 minus 20 equals 13. 2x minus 17 equals 13. 2x equals 30. X equals 15. Your solution is called an ordered triple. Your solution is called an ordered triple because there are three unknown variables. So when you write it, and we write it alphabetically, x, y, z, it ends up looking like that. Okay, let's take a look at the second example. First equation has three unknowns, the second equation has two unknowns, and the third equation has two unknowns. And what you should notice here is you can use substitution or elimination, but the idea is that your goal is to get the 3 by 3 system down to be like a 2 by 2 system like we did in problem 2a and 2b. And so if we look here, we see that we have a little mini 2 variable system within the 3 variable system. So we can use our techniques of substitution or elimination to solve. So I think I'm going to use substitution here because I can rewrite this third equation as y equals negative 5z plus 6. And then I can go to the second equation, and in place of y, I can substitute negative 5z plus 6 minus 3z equals 1. So now I'm using the technique that I just showed you, substitution, to solve this little mini system inside of a larger system. Negative 20z plus 24 minus 3z equals 1. Negative 23z equals negative 23. So I'm combining like terms, moving the 24 to the other side. Z is a positive 1. Now I can take that and plug it in and solve for y. So y plus 5 times 1 equals 6. So that means y is 1. And then I can go all the way back up to the top equation. X plus 2 times 1 plus 1 equals 4. So x also equals 1. And so the solution to my system is 1, 1, 1. All right, let's move on to the third one, which is a little more complicated because each of the equations have 3 variables in them. So our goal is to take this 3 by 3 and eliminate the same variable twice. So I'm going to write that down. Eliminate the same variable twice so that we end up with a mini system like we had in number 4. All right, so I'm looking around and I see that if I look at the first 2 equations, and again, this is a choice that you decide to make. I'm going to eliminate the y in the first 2 equations. So I'm going to rewrite the first equation, 3x plus 4y minus z equals 17. But I'm going to take that second equation and I'm going to multiply through by the number 4. Okay, I'll maybe color it pink so you can see what I'm doing there. So that's going to give me 20x minus 4y plus 8z equals negative 8. So that's my first manipulation there. I am multiplying the second equation by 4. Now I'm going to add those two equations together. It's going to be 23x plus 7z equals 9. And so I added the first and the second equation together and eliminated the y. Now I'm going to add the second and the third equation together and eliminate the y. But in order to do that, I'm going to have to manipulate, and I'm going to choose a different color now. So I'm going to choose blue, the second equation by a different number. So I'm going to multiply the second equation by a negative 3. Okay, so I'm going to multiply the second equation by negative 3. So that's 5x minus y plus 2z equals negative 2. So that's going to be negative 15x plus 3y minus 6z equals 6. Then I'm going to go ahead and write the third equation. 2x minus 3y plus 7z equals negative 21. And now I'm going to add those two equations together. So that's going to be negative 13x. And notice that the y's drop out, plus z equals negative 15. All right, so now what I have here is I have this equation and I have this equation. And so now I have created a mini two-variable system, and I'm going to solve that using my traditional techniques. So I'm going to write that second one below it. So 23x plus 7z equals 9. So now I've got this system that I'm looking at. What should I do to eliminate one of the variables? Well, if I manipulate this equation by negative 7 and add it to the below, it will eliminate the z. So negative 13 times negative 7 is 91x minus 7z. Negative 15 times negative 7 is 105. 23x plus 7z equals 9. So here we go. 91 plus 23 is 114x. The z's drop out equals 114. And so x equals 1. Now at this point, what do? We'll go back to any equation where you have an x and only one other variable. Don't go all the way back to the beginning because we still don't know what y and z are. So I'm going to take that x and I'm going to go back to one of the two, the blue or the black there, and substitute it in. So 23 times 1 plus 7z equals 9. So 7z equals 9, subtract 23, which is negative 14. And so z is negative 2. And then you're going to go all the way back up to the first equation. So 3 times x, so x was 1, plus 4y minus a negative 2 equals 17. And so we have to solve that. All right, so that's going to be 4y. That's going to be 3 plus 2 is 5. Subtract it from the other side. That's 12. So y is 3. And so my ordered triple is 1, 3, negative 2. These take a lot of work. So let's go back and just revisit what we did here. We looked at the equation and we decided what variable we were going to eliminate twice. And so I chose y. Now you might have chosen x, or somebody else might have chosen z. There's more than one way to do these problems and still get to the same solution. Okay? All right, so why don't you pause for a minute and see if you can try the next problem. And if not, then you can put in the blank, I don't know how to do it. And that'll be something that we go over in class. All right, so I'm seeing my third equation has an x and a y, right? So I'm going to take the first two equations and eliminate the z variable so that I have a mini system with just x and y. Well, if you look at the first two equations, if you add them without doing any manipulation, the z's automatically drop out. So that's 4x plus 3y equals 10. Okay, so add these two right here. And then 2x plus 2y equals negative 6. And now we have a small little system that we can solve using elimination or substitution. I'm going to do elimination. As I'm looking at this, I'm going to multiply the second equation by negative 2. And that's going to give me 4x plus 3y equals 10. The first equation doesn't change, but the second equation becomes negative 4x minus 4y equals 12. Add those two equations together. The x's drop out. You get negative y equals 22, or y equals negative 22. Now you're going to go back up and substitute it in and solve for x. So 4x plus 3 times negative 22 equals 10. So 3 times negative 22 is negative 66. So that's 4x minus 66 equals 10. Add that 66, it's going to be 4x equals 76. 76 divides 4 19 times. Okay, so the very last thing we need to determine is what is z. So we're going all the way back up to that first equation now because that's the only, or the second one. I'm just going to go to the first though. 19 plus 4 times negative 22 minus z equals 15. So that's 19 plus 4 times negative 22. So that gives me negative 69. So negative z minus 69 equals 15. So I'm going to do 15 plus 69 is 84. So negative z equals 84 and z equals a negative 84. And so my order to triple is 19, comma, negative 22, comma, negative 84. Whew. And that is solving 3 by 3 system.